In this lesson, we're going to talk about what it means to divide with an exponent. So I have some exponents here set up for us. To start out, we're going to do x to the fifth divided by x to the third power. And remember, you can always expand these out to kind of see what you're dealing with here. So x to the fifth is 5 x's multiplied together, and x to the third is 3 x's multiplied together. Now, what you can do when you have the same things in the numerator and the denominator and everything's being multiplied is this thing called canceling out. So just to clarify, as long as there's no plus or minus signs, okay, no addition or subtraction anywhere here, it's just straight up multiplying everything in the numerator, multiplying everything in the denominator, you are allowed to cancel out things that are the same on the top and the bottom. What that means is that if you have an x on the bottom and an x on the top, they can cancel each other out. Okay, so we can cancel out all 3 of the x's on the bottom, leaving us with just 2 x's on the top. So x times x would be x squared. So x to the fifth divided by x to the third would be x squared. And the reason this works is because let's say that x had been 2, okay? So 2 to the fifth power, 2 times 2 times 2 times 2 times 2 over 2 to the third power, 2 times 2 times 2. I'm going to multiply all these 2's, and then I'm going to go and divide 2 times 2 times 2. I might as well not even multiply those last 3 2's at all, because it's just going to undo them, okay? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, so the entire numerator is 32. But then I'm going to divide 2, so now I'm back to 16. Divide 2 again, I'm back to 8. Divide 2 again, I'm back to 4. So I basically didn't need any of these because I did them only to undo them. And I'm left with 2 times 2, which is just 4. Same idea here, b to the sixth over b squared. That would be b times b times b times b times b times b, b to the sixth power over b times b. We can cancel out 2 of those b's. Doesn't matter which ones we cancel out. So 2 b's can cross out with 2 b's from the top, and I'm left with 1, 2, 3, 4 b's that are still getting multiplied together in the numerator, so b to the fourth power. And you may have noticed, hey, there's a little bit of a pattern here. If I do 5 minus 3, I get 2. If I do 6 minus 2, I get 4. Is there a kind of a trick way, like with multiplying with exponents, where I don't have to expand everything out? And the answer is yes. For instance, here, c to the ninth power over c to the third power would just be c to the sixth power. 9 minus 3. That would get me c to the sixth. Again, there would be 9 c's in the numerator, 3 c's in the denominator, and those 3 c's are going to cancel out with 3 c's from the top, which would leave 6 c's left over in the numerator. What happens, though, if you have something like this? a to the fourth divided by a to the seventh. Okay, if we use our little kind of cheat rule here, 4 minus 7 gets us negative 3. Okay, make sure you don't put positive 3 there because it's the numerator's exponent divided by the denominator's exponent. So 4 minus 7 would be negative 3. Well, this negative means something. When I have something to the negative power, that actually tells me that this isn't quite right. There's something more to this problem. And when I expand it out, you're going to see what that is. Okay, if I have a to the fourth power, so a times a times a times a, over a to the seventh, a, how many is that? 1, 2, 3, 4, 5, 6, 7. Okay. Then when I go to cancel things out, okay, those a's cancel, those cancel, those cancel, those cancel, something different happened this time. Instead of the leftover variables being in the numerator, the leftover variables are in the denominator. That means everything on here got canceled out. Everything in the numerator got canceled out. 1 is all that remains. Okay, in any fraction, if you cancel everything out of the numerator or the denominator, there's always a 1. And if it's the numerator, we have to show the 1. How many a's are left over? a to the third power. What that means is a to the power of negative 3 and 1 over a to the third power are the same thing. We just took 2 approaches. Here we use the little trick rule where I can just subtract the exponents and I get a to the power of negative 3. Here I actually expanded it out to see that, oh, those 3 a's are supposed to be in the denominator. In other words, they're being divided instead of multiplied. Okay? So when we have a negative exponent, the rule is that we don't leave a negative exponent in the final simplified answer. If we end up with a negative exponent, we should look at this and say, you know what, this -3 means that there are 3a's being multiplied, but they're actually being multiplied in the denominator of the fraction. So you can put it as 1 over a to the third. Okay, so notice that it's no longer a negative exponent, now it's a positive exponent. The negative exponent just tells us, hey, I'm in the wrong spot right now. I need to be a times a in the denominator. And we're going to talk about this a lot more when we really get into the negative exponents. B to the 5th over b to the 9th. Okay, if we follow along with that rule, 5 minus 9 would be -4. And remember, that means that the 4 b's are in the wrong spot. They shouldn't be in the numerator. They should be in the denominator. And again, if you need to see them expanded out, don't be afraid to write all those out. B, 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 B. Okay? Especially for the first few. If you really need to just kind of see it like that, okay, you can get a very clear idea here how everything disappeared from the top, so I'm left with 1, and there are 4 b's left in the denominator. What about if you have x to the 8th over the exact same thing, x to the 8th? Well, what's 8 minus 8? X to the power of 0. And if you'll remember from the basic exponent rules, anything to the 0 power is always 1, okay? Another reason for this is because when I expand this out, if I show all 8x's and all 8x's, they're all going to cancel each other out. And we talked about up here that if everything cancels out on the numerator or the denominator, you're left with the number 1. So if everything cancels out in the numerator, you're left with 1. Everything cancels out in the denominator, you're left with 1. And 1 over 1 is just 1. Another example, I'll make it a little bit smaller here, would be like x to the 3rd over x to the 3rd. Okay, so x times x over x times x times x. They all cancel each other out, which means you're left with 1 over 1. Okay, what if we throw some coefficients in here now? What's 8 divided by 2? It's just the number 4. And then x to the 6th over x to the 4th. So remember, you can expand them out if you want to, or you can just do 6 minus 4 and find that you'll get x to the 2nd power. What this means is when you expand all those x's out, the 4 here are going to cancel out with 4 from the top and leave 2 behind. Same thing over here, 15 divided by 5 is first. Okay, the reason that the number, the answer to 15 over 5 goes in the numerator is because really what I'm doing is canceling out. 15 is 3 5s and 5 is 1 5. So the 3 goes on the top. The 1 would be in the denominator, but remember in the denominator, I don't have to show a 1. I'm allowed to just leave the denominator empty if I need to. B to the 3rd over b. That's really b to the power of 1. So that would be b squared. 3 times b squared. Okay, this is an interesting one. 18 and 12 don't divide evenly. But just like up here when I said I was canceling out numbers, you can cancel numbers out that are common to both 18 and 12. For instance, the number 6 is a common factor of both 18 and 12. Okay, so if I take 18 and divide it by 6, I would get 3. If I take 12 and divide by 6, I get 2. And what that means is in my simplified answer, there will be a 3 in the numerator and a 2 in the denominator. C to the 8th over c to the 3rd. Again, 8 c's on the top, 3 c's on the bottom. The 3 c's on the bottom will cancel out 3 of the c's on the top and leave c to the 5th power. Now, when I do this little bit at a time, my answer ends up kind of looking weird. Like, see how I have this very long fraction bar here? So sometimes I like to just clean it up afterwards, make it look a little bit nicer, center the 2 and everything. 12 divided by 4, that's just going to be 3. A to the 7th over a to the 10th. Okay, so we can see this is going to be 7 minus 10, which will be a to the power of negative 3. The other way you can look at it is the 7 a's on top are going to cancel out with 7 of the a's on the bottom, leaving 3 a's on the bottom. So remember, we should change the negative exponent. So 12 divided by 4 is 3. The 3 stays 3. It's really 3 over 1. Okay, so the 3 stays on the top. A to the negative third comes down below to be a to the power of 3. Because remember, if I expanded out all those a's, the 3 leftover a's would be on the bottom, not on the top. But if I do the little trick, I get a negative exponent, and that just reminds me, hey, by the way, because I'm negative, that means I am supposed to be on the bottom of this fraction, not at the top of this fraction. Over here, we've got negative 12 divided by positive 3. So we've got negative 4. X to the 8th over x to the 4th will be x to the 4th. Okay, these 4 will cancel out with 4 of the ones here, and 4 will still be there. Y to the 3rd over y squared. So the 2 y's will cancel out with 2 of the y's here, but leave 1 behind. So everything stays in the numerator. Remember, there is just a 1 hanging out in the denominator because everything got canceled out. But you don't have to show that. Okay, normally we would just write it the way I had it, negative 4x to the 4th times y. 24 divided by negative 3 would be negative 8. A to the 7th over a to the 2nd power. So 7 on top, 2 on the bottom. These 2 will cancel out with 2 of the a's up here, and you'll be left with a to the 5th power. But b to the 3rd and b to the 5th, these 3 b's will cancel 3 b's here, leaving 2 b's behind in the numerator. And you'll notice that I did that a little bit differently than before. Okay, I could have done the 3 minus 5, and I would have gotten negative 8, a to the 5th, b to the power of negative 2. And then I would have to do that extra step after that of taking the b to the negative 2 power and placing it in the denominator where it's supposed to go. But I kind of just logically looked at it instead and said, you know what, the 2 extra b's are going to be in the denominator in this one. All right, just a couple problems left to go. This is kind of a tricky one. You get negative 2 divided by 10. Okay, so this is kind of like, imagine this is simplifying a fraction. Okay, if I just had the fraction negative 2 over 10 and I said, can you simplify that? You would say, yeah, I can divide by 2 from the numerator and the denominator, and you're left with negative 1/5. And it's the same idea here. Okay, you're canceling out, and you're left with 1 and 5. Okay, so over here, you've got negative 1 and 5 in the denominator. Now we can move on to the x's. There's x to the 11th in the numerator and x to the 5th in the denominator. So these 5 will cancel out with 5 here, and you'll be left with just 6 of them in the numerator. Z to the 2nd over z to the 8th. Remember, we can do 2 minus 8 and get z to the power of negative 6, but that negative tells me, oh, those z's are supposed to be in a different spot. So instead we can look at it logically and say, hey, there's way more down here than up here. The 2 here are going to cancel out. 2 of them are going to cancel out down here, and there's going to be 6 left over. Where will they be left over? In the denominator. And if you wanted to clean this up a little bit, remember, you don't have to show a 1 in the numerator. Actually, you don't have to show a 1 at all if there's anything else in the numerator or in the denominator. So I can just leave this as negative x to the power of 6, cancel out that 1 completely, and then 5 over z to the 6th. Okay, last one here. 15 over 20, same idea. We're going to factor out anything. They both have 5s in them. There's 3 5s in 15, and there's 4 5s in 20. So my fraction is going to start with 3 over 4. M to the 4th over m to the 7th. 4 minus 7 would be negative 3. I can write m to the power of negative 3, or I can say, you know what? That means that those 3 m's are in the denominator, not in the numerator. Okay, so you can see here the 4 m's will take out 4 of the m's here, and you'll be left with just 3 m's. All All right, now here's where things get a little tricky for some people. They just start kind of getting flustered when you have a 0 exponent. So just remember, whenever you have zeros in exponent, the entire thing just becomes a 1. So basically there aren't even any n's left. So you don't have to worry about them. You know that there are n to the 3 left over down here. There's nothing for it to combine with up here. You're just left with this. And again, this looks like a weird fraction, so I'm going to center the 3 and center everything else. You can see how it looks a little bit better. Okay, so that is the basics of dividing with exponents. Again, brief recap. You can always, always, always expand everything out and just cancel things out from there. So if you forget the rules, you forget how all this works, always start by expanding, and you'll probably pick up the pattern pretty quickly if you have several of the same type of problem. The trick rule is when you have the same base, you can subtract their exponents, okay? And then that number will end up being in the numerator, whether it's positive or negative. If it is negative, what that negative means is that those A's, those 3 A's in this case, were supposed to be in the denominator. So you would change it to 1 over a to the power of 3 to show that correctly. We're not supposed to have negative exponents in our final simplified answers. If you expanded it out, you would have already seen that a to the 3rd shows up in the denominator anyway. And everything cancels out of the numerator, so a number 1 is left there instead. The other thing we wanted to talk about is when you have coefficients in the front, okay? 15 divided by 5, something like that just divides evenly into 3, but they don't always divide evenly. Sometimes you have something like 18 over 12. So you reduce that fraction. 18 over 12 reduces to 3 over 2. So it's another one like that. 15 over 20 reduces to 3 over 4. 2 over 10 or negative 2 over 10 reduces to negative 1 over 5. So when you can't actually divide the coefficients, you reduce them if possible. And that is dividing with exponents.